Hi, hello everyone. Good evening. Today we are going to discuss about linked list and binary search. So, what do you know about linked list and binary search? Just let me know in the comment. We'll be starting soon. And I have given you some problem practice set that was for combination and parenthesis. So just let me know how you have done, like if you have done it. Otherwise, we will do it here for sure. Okay, good. I haven't told any question as of now. I just told you that today we are going to discuss about linked list and binary search. So last year I gave you some questions. So let me know if you have done it or if you have any problem or if you have done it, how you did. If you have done it, like it's great that you are learning. But if you haven't done it, it's okay too because question were quite tough. Okay, good. Okay, it's good. Okay. Then we can start in linked list from base. So have you done the last class problem? The parenthesis, valid parenthesis, and um, combination generation. See, we can't say anything about any programming language. Like it depends upon your use cases. Like if you have to do competitive programming, CP, I will suggest to go with CPP, C++, because I have used Java, Python, and C++ all three, but I feel myself more comfortable and confident while giving contesting code forces in C++ only. So I will prefer C++ only, but it depends. Like if you have to do development and all, then sometime Rust, or like if you have to go with Linux terminal, then you can go with Ruby, or depends. It depends on what, but you have to do competitive programming in DSA. I will suggest to go with CPP. But if you are doing with Java, that's good too. You don't need to change the language. If you are in a final year, uh, using for placement, if you are like very in the very beginning, you are learning, you can just try learning C++ if you don't know. So, did anyone of you have tried this question? Advice for AI/ML student, I could suggest that uh, just know. See, skill set is the things that going to matter. So if you are doing anything, just do your best in that. If you have like mugging up with not going to help you anyway in an interview or somewhere, you are going to stuck, and this will like affect you a lot. So better like whatever you are doing, just do by heart, understand each and everything. So that's it. Resources is available everywhere. You can get the resources on YouTube or net, Google, Chat GPT, everywhere resources there. Just you have to use it. Just be dedicated, and that's it. You can do it. It's easy. Be disciplined. That's it. That's what the only thing needed. Because if you are doesn't depend from what kind of colleges you are, it's the skill set that is going to matter. Okay, so let's I will explain you the question and we'll see how can we do this problem, what are our observation in this. So this problem suggests that you are given an integer n and you have to return all combination of well-formed parentheses that consist of n pairs of left bracket and right bracket. So for n is equal to 2, let's see as per example. So for n is equal to 2, what could be the possibilities? We have to make valid bracket only. So possibilities is this, it could be bracket, this could be bracket. Other than this, there won't be any possibilities. These are possibilities with n is equal to 2. With n is equal to 3, what could be the possibility? Let's see. This. This is the first one. Second possibility is this. Third possibility is we can make it like this. Other possibilities. Let's see. I wrote it here. Sorry, the PPT is written. This one, this one, this one. So overall, we can make 6. So it could be we can make it like this. Similarly for right side, like this. And one more is there, which is no, only 5 possibilities are there. These are the only 5 possibilities with 3. So how can we generate all the possibilities? Within this question, n is given to you. This is given. You have to generate all the. Suppose for n is equal to 3, your answer should be these 5. So first thing that we need to observe that for n, suppose whatever n we have, there will be 2n total number of brackets, right? In which n left bracket will be there. We will go with basic. with our observation, what it will be. It's so simple. Just don't make it complicated. So n left bracket and n right bracket will be there. Okay. You know. So what could be the other observation? This could be there. So suppose we are making this bracket sequence of 12. This is 12k. For the timing, let us assume 12. This size is 12. Then if we made this kind of sequence, then we keep the record of how many left bracket we used so far, L, and how many right bracket we used so far. So the possibility of this would be, if for this position, for this position, for this index, if L number of left bracket is greater than R, this could be the possibility. This will, if this is condition is there, it means that the bracket sequence up to this is valid. Left could be greater than right because there are some spaces in the right where we can place a right bracket like this. Okay. But what if at this position up to now R is greater than L? Means right bracket is greater than left bracket. In this case, you can't figure it out. Suppose you have one left bracket and two right bracket. In this case, whatever value, whatever bracket you fill at this place, it won't be like you can't make it done, right? To make it compensated, you need something like left bracket at this place, which you can't do. So in this place, answer won't exist. In this case, answer exists. Okay? So we rejected this case like this shouldn't be there. R greater than number of right bracket greater than left bracket. It shouldn't be there. So now let's move on with this condition. If L greater than R, if L greater than R, if this is a condition, so what could be the observation? At this point, L greater than R, right? This is true in this area up to now. Number of left bracket is greater than this. If this is true, is it beneficial? Is it can we place at this place the right bracket? Definitely we can place since it will be countering some left bracket. This right bracket will be countering some left bracket which we have used before. And since L is greater than R, it's good. Like it's feasible to place this right bracket at this place. Now the question arises, can we place left bracket at this place? Can we place? So we can place, but one constraint we have is number of left bracket would be only equal to n, right? You can't have left bracket number greater than n, right? Because n will be left bracket, n will be right bracket. So total 12 bracket will be there. So if this condition is true, L greater than R, we can always we can always have right bracket here. And if this condition is true, with this standing this is true, when we can use this, if number of left bracket is less than n, means that we can place this bracket at this place, at this index, we can place this index, and again using recursion, we will be passing it to our friend function from starting from here with an updated value. Like if we do this, so what will be the number of L will be same, the number of R will be R plus 1, because here we used earlier we have L left bracket and R right bracket up to this place. At this place we use a right bracket, so left bracket number is same but right bracket is increased by 1. So again at this place when we are passing this parameter in the function, it will be L and R plus 1, and here in this case it will be L plus 1 because we added this bracket here. Wait. L plus 1 and R. So this is the condition. So I hope you understood it. So let's go by coding. Let's code it and see what happens. Okay, give me a second. Yeah. Let's go. So in this, let's take int n input from the user. We took the input. Now we need to make a function. Let the return type of function be if, and if is the name of the function. And function will have the parameter as string, right? String will be our current answer, current string. Like as I have told you, if I am in this position, so what is my current string? What is my orientation? How many left bracket we have? How many right bracket here? And what's the string? Like if it is like this one, left, left, right, 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 left, left, whatever the string we have, it will be stored here in this str string str. Okay. Then we will have a parameter left. That will point the number of left bracket we used so far. Then we have right, and then we use a vector to store all the possibilities in the end. Vector of a string answer. Okay. Then what is the condition? If L is less than R. Sorry, let me check what's the condition here. If L is greater than R. Sorry. Okay. If L is greater than R, its number of left bracket, not L, it should be left. If number of left bracket is greater than R, it means that we can use right bracket, right? So let's pass str plus like this. We are inserting the left bracket at this place. Okay. One thing you can do, like I have selected this question on lead code tool. You can do it here even. If you want to do it here, you will understand it better because we are doing it from scratch here. Okay. So this, and since we are using left here, left will be left plus 1. Sorry, left is greater. Sorry. Left is this, and we will be using this right bracket here. Left is greater than right. See, left is greater than right, and right bracket we can use. For using left bracket, we need to check this condition too. Okay. So if this is true, left plus 1. Sorry, left will be same. Right plus 1 and edited string answer. Okay. Now this is done. If other condition we have is if L left is less than n, second condition. If left is less than n, we will be using left. If str plus this left string left plus 1 right and answer. Okay. I hope this is correct. And then return. What would be the base condition? Base condition is that if string length, if str dot length is equal to 2n. Sorry, we need to pass n in the parameter 2. And left equals into n. You have to pass n here too. And if this is length is 2n, we will be inserting the string in our answer. Insert our pushback str, and we will be returning. Okay, so let's see. We are done with this. We need to take care of vector of string. It will be storing the answer, all the function. So now we will be calling the function. Function will be, we will be starting with null string. Initially our string will be null, right? We don't have anything, so we'll be starting str with a null string, and now we are passing this str and as per our function, left, right. Left is initially is 0, right initially is 0, and the answer in which the answer will be stored. So now when we call this function, all the possible parentheses will be stored in this answer, and we can just run the for loop in j is equal to 0 to j is less than answer of size. So this way, let's see if it works. Otherwise, we'll okay, it's not printing anything. Let me see where it is here. Okay, we are not inserting any input here. So because of this, let n is equal to 2. Okay, let 2 and see what happens, how it works. Yeah, it's giving all the possible output. For n is equal to 3, let's see how many output will be there. See all the 5 possibilities we are getting for n is equal to 6. These are just small values. Even I was facing difficulty in for n is equal to 3 to write it manually. So like we want to check it for 5, even 5. Let's see what happens with for 5. How many outputs we have? See, these are the possibilities. It generates all the possible answers for 5. I hope it is clear to you. It's a bit difficult. Just understood. See, it's a bit difficult to understand and code it in the first go. So better if you understood the logic. If you understood the logic, just go by basic. Logic is pretty simple. We are observing what we are having, left bracket, right bracket. On the basis of number of those brackets, we will be making the condition here. What should we do? If L is greater than R, we can place the right bracket. If L is less than, if this condition is not true, we can't do anything. If right bracket is greater than L, we can't do anything. We can't move forward. But if this is true, then there will be two cases. We can always place a right bracket at this place. And for placing a left bracket, the condition should be the number of left bracket we have used so far should be less than equal to n. Otherwise, we can't move forward. So if we are doing this, the number of left bracket up to this current index will be L plus 1 because we used L1 bracket here. So it will be L plus 1. And for this, it will be L and R plus 1. I hope this is clear to you. Just let me know. Yeah, good. Let's move to the next question. Yeah, base case works in this way. See, what would be the base case? If the string length is 2n, that's what we want. If the string length is 2n, we are into the base case. In that case, whatever string is our current string, okay? So whatever string value we have, we will be pushing it our answer array, answer vector. We will pushing it to this string. We are pushing that. So this is how it works. See, like if you have 2n, there isn't any point of moving to 2n plus 1 or something, right? Because if you go below, it will be inserting some element. This either in this one or this one. So length will be getting increased, but you want the string to be of 2n length since n is given. So that's why I hope you understood. And here we are returning because we don't need to. At this point, we got our answer. We don't need to go down. I hope you understood this. Yeah, let's move to the next question. Next question is that you are given uh, for this. Okay, let's go for this only. You have to use one possible combination. So let me modify it for the time being, or let it be whatever it is. So this question says that you are given two integer n and k, and you have to return all possible combination of k number out of the number from 1 to n. So let me explain you the question. The question says that you are given n and k. N is given to you and k is given to you. So you have number like 1, 2, 3, 4 up to n. So for the timing, I'm assuming n to be 5, okay, and k is equal to 2. So you have to take all possible combination of two numbers from these n numbers. So what does it mean? What all possible combination of k of size 2? You can do 1, 2. You can do 1, 3. You can take 1, 4. You can take 1, 5. You can take 2, 3, 2, 4 in this way. I hope you understood. And 5. Then you will be going with 3, 4, 3, 5, 4, 5. So these are all the possibilities. I hope you understood this. Understood the problem. You are given n and you have to find k, find all possible combination of k number choosing. So what will be number of this? Like how many combination we can make? It will be nck, right? It means that from the n number, you have number of ways to select k number from n number, right? So that's what it is. So let's see what we can do. So it's like we can take it in as an array. Just go by basic, just whatever you know, just try to write it in this form and do some observation what you can do for a particular index. So for number is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, let it be. Our value is 9. So what we can do for this index? Suppose we have total we have to take k number, right? So for this number, our choice is that either take this element or don't take this element. If you take this element, you take this. Now we need to select k minus one element. Since in total I have to select k element. I selected one element, so I need to select k minus one element from here, from this second index, and at this place, what is the other possibility? This is the first possibility. I took this element. Other possibility is that I don't take this one, so I don't have anything, right? So I need k element only, but now from this index. Sorry, but now from this index. Since at first index we haven't took anything. Again, we will came at this index. So it will be like if I show you in terms of function. So if index is the I, and number of element we want. Number of element that is initially we want k will be k. So at first index, let it be like we are initializing with 0. So we are at 0 what we want. We can take this element, right? We can take this element. Let's take 1. Okay. Then how many 1? Then we need to call this function again with index 1 and number of elements we want is k minus 1. We can, because we got one element, right? What is other possibility? We don't take this element. Then again we will go to the next number, index 1 with k requirement. I need k number. Then again, from this position, there will be two possibilities like we had before. What will be that two possibilities? It will be if either I will be taking, since up to now I have one number, one I took this from here, one will be there. Again, the choice is that if I take this element 2, the possibility is that again I will be starting from 2. Now the number of elements we require further is 2, because here one we take earlier and now again we are taking 2. So we take 2 elements. Now we require k minus 2 extra element to fulfill k element. Okay, and here it will be like we didn't take 2, so 1 we have from here, and again we were moving to index 2 but k minus 1 since we haven't taken any element here. So this is what we call recursion tree. It's like a tree kind of structure, right? Similarly, for this there will be two condition. Again, for this there will be two condition. So what will be the base condition? So what will be the base condition? Base condition is that we don't have any element to add. Like if k is done, we are done with k. If k is equal to 0, it means that we don't need any element. Then it means that we got an answer, right? We got k element. We have such k element at this place, right? Whatever, suppose you have 2 number, then it is 2 minus. If it is 0, it means that here we have k numbers. So we got k number as an answer. So we will be inserting this whatever current this vector will have, we will be inserting that in our answer. Okay. Other condition is that this I index, if it go greater than n, then we need to return, because that's we can't do. We have to select number from 1 to n only. So right, this in this case we will return it. We can't get any number. We can't take any number n plus 1 in our combination. So these are the base cases, and these were the two cases. So let's code it. So let's code it here, and we can do it here too. Let's solve it here. Okay. Just we can do it in a k. Return all possible combination of key numbers chosen from 1 to k. Okay. So n and k is given to us in this function. Okay. So let's go. We will be defining a function void f in I will be the index, and then we will have k, right? K. Then we will have a current vector that will store how many elements we have as of now. Current, and one is a vector of vector that will be store our answer. So let's write the base condition first. The base condition is that if index if k is equal to 0, it means that we got our answer. Insert the current in answer. Answer dot pushback current. Okay. Now we need to return it from here. Return. Other base condition is that if index is greater than n, we need to add in here. We need to return, right? We will be returning this. This other case is that if we take this element, we will be pushing it back. Push back index. Then if we are taking, so we will be moving to the next index with n, with this current, and k minus 1, sorry, and k minus 1, because we got this element, we got an element, so we need k minus 1 element now. Answer, and we will be popping it back for the case. Second case, if we don't take element, we will be moving to the next index, but still we have the requirement of k number. Then we will be moving again to the next, and This is how it will be then return. Okay. So now let's call the function. Let's make a vector current vector of vector that we will be returning as answer. Okay. And this is done. Let's call f a function with starting from 1 since we have to take number from 1 to n, right? So we'll be starting from n. N is given to us, k is given to us, current we have declared, and answer we have declared. So whatever this function will be called and whatever answer we have will be stored in this answer. So we have to return this answer. Right? Return this answer. Let's see. Yeah, it is getting. Yeah, it's getting past. So let me know if you have any doubt, or we will move to the part today's session, which is for linked list and binary search. See, I can say a bit louder. The concept is that for each place, the concept is that for each place, I have to decide. There will be two conditions. Either I will be taking this element or I will not be taking this element. If I take this element, then the number of elements we require. So initially we require k element. Initially we have like null set and we require k element. Then what will be the possibilities for us? For the first index, we will either we can take this element one or we don't take this element. If we take this element, then what other element we need? What is the number? We need k minus one other element, right? If we don't take this position, we will have null set for now. Still, we need k. Okay, this is what here we took k. Then we will be starting from one. We need k minus one number. If we don't take this first number one, then we will go to one. One is the index. It's index, so it's like zero based indexing, but number is one. So we will go to one and still we need k number because we haven't taken anything. But at this position, there will be again two condition at index one. It will be either I can take this element two or not. If you take this element, the current set will be contain element one and two. Okay. And this is how it will be. So if we take this element, the other we need to proceed 2 from index 2 to k minus 2 because we have two elements. So we need only k minus 2 more element. So what if we don't take this element 2? If we don't take this element 2, we will be moving. We have only one element as of now. Because of this one, we took this element and we are proceeding with this. So here also we have element 1 with us. So f2, but since we haven't taken any element here, if we took this is the case we took, this is case we didn't took. Okay. So we still need k minus one element. So talking about the base case, is k is what the number of element we need. If k is equal to 0, it means that we don't need any element, right? This is represent how many extra, this k minus 2 represent how many extra element we need. So how many extra element we need? So if k is equal to 0, it means that we don't need an element, right? So we will be moving, we got our answer, right? K is equal to 0. And this is our current array. So whatever at the stage when we got k is equal to 0, whatever this will be our answer. So we will be inserting this current into the answer since there will be many answer. So answer is a vector of vector. And other cases that if I is greater than n, We want the combination from number 1 to n. It is given in the question. So we can't, if it is being n plus 1 or something, we can't take. So in this case, we need to return. So this is how I wrote in the code. I didn't understood like what you are saying. Which command you should run to run output? Can you explain what you're saying? See, if I take the same code in the normal ID, it will be like you are doing nothing. You are just taking n as an input, n and k from the user, and you will be calling the function. That's it. Okay, so if you want me to print it, I can just take it here only. So for the time being, let me copy it from here. Okay. Okay, let me do it so that you can visualize. Right, because lead code is just showing that your answer is getting fast, but you're visualizing, right? So we will need to call the function with one and k and a correct answer. Okay, we call this. Let's see if it gives some error. Of 5 number and k is equal to 2. Okay, let's see. Okay, it is giving some error. Hmm. Let's see if I'm doing something wrong here. F 0 answer index 1 and k. What do you mean by second code? Like this one, combination one. I'm saying, see, this is my function. Okay, so let me explain here only. See, this is my function. My function shows that index is like which is my current element, n is a number, and k is like how many element we want. So at any point, what is the possibility? Either I can take this element. If I'm taking this element, I'm inserting that in the current. Current is the same set, this one. Like 1, 2, 1 I have here, here is null, here we have 1. This is that current, okay? Here we are pushing that index in this current vector if we are taking it. If we are taking it, we are pushing it and we are calling it with index plus 1. We are going to the next element with the requirement of k minus 1. We can, because we got this. So when this will be done, this when this function is done, we came at this place. At this place we will be here after this. But still at this place, this index will be in this current, right? So we need to remove this index. We removed it, and we now go to the case when we haven't take this element, right? Since why there is a need to remove. If we don't remove this, we are passing this current to this place. So in this case, it will be taken like indexes is here also, and it will be here. So here we take this and we are removing it before going to the next one. Okay. So this is how it is. I hope it's clear. Yeah, yeah, good. I follow. Thanks. Let's see if it works. Yeah, see, you are getting all the possibilities. If we increase the number of k is equal to 3, we will getting all possibilities of number 3. Yeah, we are getting. Now, this is clear to you. Just trying doing that will won't just run it. Just do like take a blank big page and do this. Take one, not take one, take that, and just make note on this index condition too. If it is greatly going greater than n, then we can't take it. Just reject this case. So just do it here. You will understand how it is going. Okay. Without using the pen and own paper, you can't understand. Like you will see, sometimes you will feel how it is going. Then you will learn. Okay. Yeah, so let's go to today's session. So today we are going to learn about linked list and binary search. So what a linked list is? So linked list is nothing. It's a data structure. It's a kind of this kind of data structure. It will have a data. It's this is called node. See, you have data type like integer. Integer only can contain a value. You have a string data type that can only contain a string value. But no, this is linked list is a customized data type. Like it contains two value. It contains data value and a pointer value. I'm denoting writing pointer by PTR. So what does it mean? Pointer is like this. It's point to some other node. The pointer store the address of some other node. Okay. So this is node 1, this is node 1, this is n2, node 2. Okay. This will also have some data, and this will again have some pointer that will be pointing to that will point to some other node. Wait, yeah. This will point to some other node in at this position. There will be some same case, and in the end, whatever node it will be, it will point into the null if there isn't any node out to the right of this. This is what linked list is, and this is the very basic. So if we want to know the theory of it, it will be like link. It has a pointer. What a pointer means? Pointer is just a variable that holds a memory address of another variable. So to make you understand it better, or to go into the deep of pointer, what it means. So suppose that we to define a variable int a, int a is equal to 5. So have you ever thought like how it is getting assigned in the memory in the operating system? It will be like a box will be getting allocated to a is equal to 5, right? This kind of thing you can visualize. But there will be some address, like the chip is very big. In this big chip, there will be some small place where this a is stored. So there will be some address. So address is a hexadecimal value. It's like suppose the it's like A230. This is the address of A. So what a pointer will do? Pointer will point to the address of any variable. So if I have a pointer, so we can declare a pointer is like int star, int star ptr. Ptr is I'm just writing the name of pointer. Pointer is equal to address of A. This that this means by this means that we are trying to this a is the variable, and this means that this whole means that the address of ptr store the address of a. So when we print ptr, if we want to like see out ptr, so when we print this ptr, it will print a30, the address of a. It will print this a30, the address of a. A230, sorry, address of it. This is how pointer is. Pointer is nothing but like it point to the address. And if you want to find the value at this address, PTR up to now contain the address. But if we want to find the value stored at this address, then we need to dereference it. In order to dereference it, we need to write that star PTR. It will tell us the value stored at this address equal to PTR. So if you write C out this, sorry, pen is not working properly right now. So if you have a use this one PTR, it will print the value of A is equal to 5. Okay, I hope you understood this thing. Pointer. So so you can think pointer is like a direction to a friend's house, not the house itself. Like there is a node, the direction to the node where it is living. Where is your friend house? The address of your friend's house, not house your friend house. What your friend have in his house. So how does a linked list work? Linked list, as I told you, it is each has a node. The node has a value, a data, and a pointer to the next node. This is what we have. So why use linked list? It's like dynamic size. We don't in the array when you are using it, we need to define the size at first, right? In this, we don't need to define the size. Insertion, deletion is easy. It's like you can delete an element, you can just insert the element into the back. There is two type of linked list. It's like singly linked list and doubly linked list. Singly, sorry, pen is not working properly. Singly and doubly. Singly means that there is only one way. This point to the next, this point to the next, this point to the next, like this. In the end will be pointing to null. Okay? In doubly, it will be like two-way. Like at this, from this you can go to this place, from this you can go to this place by pointer, but from this you can't come at this place because when you enter at this place there isn't any pointer. You don't know the address of this, you just know the address of this at this place because this pointer is to the address of next one only. Okay, but in doubly what happened there is a two-way. You can understand it's a one-way road, it's a two-way road. So you can go to the next, to the right, to the back. Okay, yeah, so this is doubly. Okay, so let's move. So this linkage stack, these kind of problem, like I have faced this problem in many interviews too, so better to understand it. This is a very famous for interviews. Now we see binary search. What a binary search is, this is very important. Binary search is nothing. Like suppose this is the array you are given. In the array is sorted. Array is sorted in increasing order for the time. Okay. So in this array, you have to find some element. Find the element x. Okay, you have to find this element x. So what you will do initially, you need to find element in this array. Element could be a in element x could be in anywhere in this array, in mid of this array. Okay, let this be the left part and r part. This denote the range in which this element could be. Let's define the value mid. Let's see mid. Mid will be l plus r by 2. So mid will be somewhere here, right? So for this mid, we will check the suppose the value at this mid position A mid is the name of the array. I'm sorry, the pen is not working. So suppose this is the value at A mid. If this value is greater than target, if this value is greater than x, it means that the x must lie in this area only, right? If this value is greater than x, since it is in sorted in increasing order, the value is that these all value will be greater than x, right? This all value. So we don't need to go this place. So our search space reduced to this only. Next time we need to search in this only. And if x is greater than this mid value, this one, a mid, then x can't this all value to the left of it is smaller than x. It is smaller than a, so definitely be smaller than x2. So in this case, we need to find in this area. So again, we will be modifying. This will be our new one. If like if we have search in this area, we will be modifying our L to this, and R will be still on this. Okay. Then again, we will define our mid will be this L plus R by 2. The mid will denote some value at this place. Okay. So we will check which side we have to go depending on the comparison. If this value is greater than x, if this value is greater than x, then it means that these all value will be greater than x, so we need to move to this. If this is lesser than x, if this value is lesser than x, then it means that all these element in this set will be lesser than x, so x must be in this side. So we will be searching this space. Then again we will be modifying. So suppose this our search space is this, L will be this again same, L will be again same, and R will be this. We can change this R because in this range only we have to search. So this is how it works, and uh, in this ultimately there will be a point when we came like mid is equal to L or R, and at that point we will be searching element at this place. We will get the element here. Okay. So I hope you understood this how it is working. So I will write the pseudocode. Like the pseudocode, it will be like while loop will be there. While L is less than R, it will work when L is less than R. When while L is less than R, we will define a variable mid which is equal to L plus R by 2, and we will check if mid value, A mid value, let me do it by hand only. If A mid value, suppose A if A mid value is equal to is greater than X, the target, then it means that if A mid value is greater than X, it means that all the values to the right are greater than X. So R, we need to shift the R to mid. We need to shift this R to mid, right? How can we see this? See, this is what we have done. If this value, if this value is greater than X, so it means that these all values are greater than X. So this is our search space. We will be so this is our search space. L is same. Now our R should be this. R is equal to mid. So this is what we will be doing. R is equal to mid. If this opposite is true, less, then we will be moving. We will be moving it to the right. L is equal to mid plus 1. Okay, then L is equal to mid plus 1. So let's do the coding part, or we can search this int n and x. C int n x vector just makes your binary search works in a particular arrangement, like it should be sorted or that. If you are using binary search and answer, it should be, there should be some pattern. Okay. For int j 0 j plus plus. For if vj done, we got vj, then we will write a binary function to find l is equal to 0, r is equal to n minus 1. Okay, now we will write the while l less than r. We will define mid r by 2. Now we will check if a not v mid. If v mid is equal to x, this means that this is my element. We got the answer, right? Int answer. Okay. Let it initialize this to -1. Answer, we got the answer. Answer is equal to mid. The element is at mid position, this position, right? We got this. So in this case, we will be breaking up the loop. Else, if v mid is greater than x, if this v mid is greater than x, if this is greater than x, so what would we do? It means that all the element to the right will be greater than x. So we need to move r to this position. R is equal to mid. If v mid is less than x, it means that all element to the left is less than x. We need to move to right. So we need to move L is equal to mid plus 1. And in the end, if we check if answer is equal to -1, answer when answer will be -1. This is like this will be mid will be someone from 0 to n. So if this condition is true any time in the program, that its value won't be this value won't be -1, right? This will only be -1 if this condition is not getting executed. And when this will not be getting executed, only when there isn't any this condition is true. It means that there isn't any element in this vector. So in this case, this will be true. It means that this element not found. Else, next we will add that index and so let's see if it works. 5 5 3, we have to search 3 1 2 3 5. Let's see if it works. This is 5 is the size of the element is at index 2. We are getting correct. 3 is at index 2, like 0 index. Okay, so we can change it like 1 5. Sorry, it should be sorted, right? 1 3 1 1 1 3 4 5 6. So number of elements is 7. Let's see if it works in case of duplicate. We have 47. Yeah, see element is at index 3 you are getting. Now do it for some case when element is not there, like 5 3 1 2 1 2 4 5 6. Let's see if it is working correct or not. Yeah, see element is not there. It is saying element not found. I hope you understood this. So this is all. You can go with this problem. Like I can tell you one more thing. This for this problem. This is in this problem you have to detect a cycle. So how can you detect a cycle in buying linked list? See, in linked list, the possibility of this could be this is an node, node. This is a node. Okay, this will be a node. This will be a node. Sorry for bad drawing, but this possibility is like this is pointing to this. This is pointing to this. This is pointing to this, but this could point to this too. So you have to find out if there is some node exist or not. So how can you do this? If does anyone of you have any idea, just let me know. Otherwise, to just study how we can do and let me know in the next class. We will do it in the next class. Or if you have any idea, just let me know. No, we aren't covering BP here. Tomorrow, I guess we will be covering tree. Then I don't remember exactly the schedule, but tree is there as far as I remember. I can give you the hint that you can use a concept of slow pointer and fast pointer. Just read it. Just like do some research to like do mistake, then you will learn only. Okay. Okay, then we are wrapping up the session. We will meet tomorrow. Okay. Yeah, yeah, we will send you the PPT. There's a question in the PPT. See, you have to reverse the question problem is that you have to reverse a linked list. This is a very famous problem. Like I have even faced this question many times in the interview. Like very classical and very famous and easy tool. You can do it. Just try to do it and on your own. Just think about logic. Yeah, yeah, they will send you the PPT. Okay, I will send them. Okay, then see you tomorrow. Bye bye. Yeah, don't worry, we will send you the PPT. Bye bye. Yeah, exactly. We will use to fast pointer, slow pointer. So exactly.